Hi students, in this week's video, I'll be providing you with a follow-up from the previous one that I've done on trigonometry curve sketching. This video, I'll be giving you a summary of what are some of the things you have to look out for when you need to sketch or solve problems involving sine, cosine, tangent curves. And also at the end, I'll be providing some O-level questions, some tips on how we can go about solving some O-level questions. So please stay till the end. Let's start off by motivating ourselves with an encouragement quote from Mr. Benjamin Franklin. And it's written as such: an investment in knowledge pays the best interest. Right, in the previous video, I did not provide you with a in-depth explanations on how the amplitudes of the curve, how are they being related to the functions that are given. Right, so in this video, right, on the screen, I've actually shown you three different curves. The one in red is y equals to sine x, the one in blue is y equals to 2 sine x, and the y in green is y equals to 3 sine x. What we're going to do next is to observe how the maximum and the minimum points of the curve, how are they related to the functions, to the certain variables given in the functions. Right, so there are quite a few free online software, graphing calculator software. You can actually use it, right, to explore the different shapes with different functions. This one I'm using is Desmos. Okay, right. So from the graph, let's look at y equals to sine x first. From there, we can clearly see that the maximum point is the point that I have just indicated on the screen, and that it's 1, the maximum value is 1 at 90 degrees. Right, let's go on to the curve that is colored in blue, y equals to 2 sine x. And for y equals to 2 sine x, we can see that the maximum point also happen at x equals to 90 degrees, and the maximum y value is 2. Right, let's proceed on to the green one. And likewise, the green one, we can see that the maximum y value is 3, and that happens when the angle is 90 degrees. Right. Right, so what does it, what is the connections then between these three different functions? Right, you see that the angle that gives you the maximum values all happens at x equals to 90 degrees. Right. And the coefficients of your sine x actually gives you the maximum value of y. So if you can look at it again, you will be able to see the relationships. Alright, so let's go on to find the minimum value of y. So let's look at y equals to sine x first. So, right, so y equals to sine x, you will see that the minimum value is this point here. The minimum value of y is -1, and it happens when your angle x is 270 degrees. Alright, let's proceed on with the blue one. You can also clearly see that it happens at x equals to 270 degrees. However, the minimum value now is -2. And if we go on to the green one, right, it's the minimum value of y is -3 when your angle is 270 degrees. Right, so therefore, from this simple example, we can conclude that for a particular curve, y equals to a sine x. Y equals to a sine x, right? The maximum value of y would be the positive values of a and then the minimum value of y will be the negative value of a. And the angle that corresponds to this maximum and minimum value will be all at. For the maximum value, the angle will happen at x equals to 90 degrees. Then for the minimum value, it will happen at x equals to 270 degrees. Okay, so these are the basic informations you have to remember. Okay, there's no other way. And also, you need to remember the shapes of the sine curve. Right, so in the previous slide, we have studied y equals to a sine x. How the corresponding angles for the maximum and the minimum values of y. So now, if you were to look at what I've shown you on the screen, this is a different story now. What we are having now is not y equals to a sine x, but rather, if you look at the red color curve, we are dealing with y equals to 2, y equals to sine 2x. And if you look at the blue color curve, this is y equals to 2 sine 2x. And the green color one, this is y equals to 3 sine 2x. Alright, so what's the difference between, okay, so if I'm going to just to represent all this with a general form, y equals to a sine 2x, then what's the difference between y equals to a sine 2x and y equals to a sine x? So the difference lies on the range given for one cycle. So y equals to a sine x, right? You will see that the range is between 0, that means the period is 360 degrees. It's between 0 to 360. Right, so for y equals to a sine x, the period for one cycle is 360 degrees. However, for y equals to a sine 2x, this case here, then for one cycle, the period is 180 degrees. So what is one cycle? So one cycle, basically you have to remember the shape. One cycle is, the shape of the sine curve is just, you go through 4 quadrants, go up, come down. So this is your first, second, and then you go to the third and the fourth. So that's how the shapes, that's how one cycle looks like. And that's what we have on the screen here. Okay, so this is considered as, this is one cycle. Right, and the period is from 0 to 180. Okay, so just a difference. Right, so let's look at the maximum value of y now for the different curves. So for y equals to sine 2x, the maximum value of y happens at 1. However, the corresponding values of x is no longer 90 degrees. It's actually at 45. And how do we get 45? It's basically taking 90. Remember, in the earlier slide, y equals to a sine x. The maximum value of y is equals to 1 at x equals to 90 degrees. That is y equals to a sine x. What is happening now is that I have y equals to a sine 2x. So I need to take 90 degrees divided by 2 to get 45. Okay, now let's look at y equals to, now let's look at the negative value. So the minimum value of y will be negative 1, as indicated here. However, you'll see that the angle corresponding value of x is 270 divided by 2, which is 135 degrees. Let's go on to y equals to 2 sine 2x. Okay, you will see that the maximum value of y is 2, minimum value of y is negative 2. However, the angle remains at 45 degrees for the maximum value, and then it's 135 degrees for the minimum value. If you go on to y equals to 3 sine 2x, okay, maximum value is 3, corresponding value of x is 45, minimum value of y is negative 3, and the corresponding value of x is 135. Right, so what is the learning point here? So the learning point here is the maximum value of y and the minimum value of y is still the coefficients of your trigo function. Maximum is the positive, minimum is the negative. However, right now, the corresponding angles, you will have to take 90 divided by this number here. So in other words, to summarize for you, if you're given y equals to a sine bx, okay, the maximum y will be the positive a at x equals to 360. Sorry, wrong. 90 divided by b. Then your minimum y is the negative a at x equals to 270 divided by b. Right, so with this knowledge, let's put it into practice. Let's look at question 1. So for question 1, you're given that the range is between 0 degrees and 360 degrees. And we are asked to find the maximum and minimum values of y and the corresponding values of x for this function. For this function, y equals to 7 sine x minus 3. Right, so let's look at the maximum value first. So to find the maximum value, we just substitute sine x equals to 1 into the function given. So you will get 7 times 1 minus 3 gives you 4. That means your maximum value of y is 4. And that happens when the x is 90 degrees, because we're dealing with y equals to a sine x plus c, right? We're dealing with sine x. So therefore, the angle x is equals to 90 degrees to give you sine 90 equals to 1. And for the minimum value, what do? Yes, we substitute sine x to be -1. And that happened only when the x is 270. Okay, you can just use a calculator, key in sine 270, you get -1. You key in sine 90, you get 1. Okay, so therefore the minimum value of 7 sine x minus 3 is -10, and that happened when the x is 270 degrees. Okay, but what happened now? Let's look at question 2. When now the questions I'm giving you, it's no longer a sine x plus c, but it's a sine bx plus c. In this case here, it's y equals -3 sine 3x plus 4. So what we're going to do? Yes, we're still going to substitute sine 3x equals to -1. Right, so the maximum value, we can't substitute sine 3x equals to 1. If you substitute sine 3x equals to 1, then you're actually finding the minimum value. Why is that so? Because I have a negative here. Okay, I have a negative here, so I need to multiply with another negative to give me a positive, to give me a bigger number. If I have a negative times a positive number, then I'll be getting a smaller number. If I take negative times another negative, I'll get a bigger number. So therefore, I need to substitute sine 3x to be -1. So the maximum value of y will be -3 times -1 plus 4, 7. And if you remember, to get sine ax equals to -1, my angle happens at, to get sine ax equals to -1, sine 1x, sorry, to get sine x equals to -1, that happened when my x is 270 degrees, right? Right now I'm having sine 3x, so I need to take 270 divided by 3. So therefore the angle that will give me sine 3x equals to -1 happened at x equals to 90. Right, you can look at it this way if you don't understand what I'm talking. Basically, you just substitute your x to be 90, and you have sine 270, and you can just use your calculator to work out sine 270, that will give you -1. Okay, so let's look at how we can find the minimum value. So for minimum value, I will have to substitute sine 3x to be 1. So therefore, the minimum value is 1. And that happened when, yes, you have to take 90 degrees divided by 3, gives you 30. Because sine 90 is equals to 1. Okay, if you were to use a calculator to evaluate it. Right, so I hope this video will provide you with a better explanation than the previous one to understand how to find the maximum and the minimum value of y and the corresponding values of x. Right, let's continue with the sine curve. Now we all know that y equals to sine x is just the basic shape of the sine curve. It can be a variation. And how is the variation like? Yes, the sine curve can be expressed in the form y equals to a sine bx plus c, or y equals to -a sine bx plus c. Right, in this case here, your a and b are more than 0. Right, you have axis y equals to c, amplitude a, and the period for the sine curve for one cycle is 360 degrees divided by b. B is the coefficient of x. Or sometimes if the unit is expressed in radian, it will be 2 pi over b. So I'm going to provide you with an example how we can actually come up with this formula. You can call it as a formula. Okay. Right, let's start off with our basic shapes. Y equals to sine x. So if you look at the diagram there, okay, that is your axis. That is your axis, which is y equals to 0. That's your x-axis. Right, so basically this axis actually divide your curve into two equal half. Okay, and you will see that the one I've highlighted for you in green, the height of it is 1 unit here. Right, so from here to here is 1 unit. So therefore your A is equals to 1. Right, and we are dealing with one cycle, so it's between 0 to 360 degrees. So therefore the period is 360 degrees divided by 1. To get 360, you must divide by 1, because I'm using this formula. So to get 360, that means I need my B to be 1, right? And putting all this into the formula that's given, this formula here, I substitute my A to be 1, the B to be 1, and y equals to 0. It's here what we're talking about is C is equal to 0. Therefore, I end up getting this curve y equals to sine x, which is a basic shape, the first curve that we have learned before we learn all other variations. Okay, right, so let's look at another example. In this case here, you'll see that is one cycle, and it's between 0 to 180 degrees. So my period, if we were to use the formula that's given earlier on, which is 360 degrees divided by B, my B has to be 2 to get 180. Okay? And you will see that the one that I've highlighted for you in yellow is your axis of the curve that divide your curve into two equal halves. And in this case here, your C is equals to 1, because it's a horizontal line, y equals to 1, so C is equals to 1. And the height of your curve is 2 units. You just take this 3 minus 1. It gives you 2 units. So your values of A will be 2. So putting this back into the formula that we given earlier on, the formula which is y equals to A sine bx plus c. So the equations of the curve will be y equals to, the values of A is 2, values of B is 2, values of C is 1. And that gives you y equals to 2 sine 2x plus 1. And the range that we need to sketch will be between 0 to 360. So in this case here, we have 2 cycles. Okay, we have 2 cycles here. All right. All right, let's look at another example. This will be the last example for the sine curve. Right, why do I give this example? Because if you were to look at it carefully, it's different from what we have been given previously. This is an inverted sine curve. Right, it's an inverted sine curve. So therefore, the functions that we'll be dealing with will be y equals to negative a sine bx plus c. Right, so let's see how we can come up with the functions for this curve. Right, so that is one cycle. So basically you must remember, okay, one cycle, you start with 1 here. Can you see also you end, if I'm going to use a dotted line to show you, okay, so that's one cycle. Right, so the period given to you will be, period here is 720. So if you're going to substitute into the formula that we have learned earlier on, 360 divided by B, my B has to be half, because 360 divided by half, then you get 720. So here my b is half. All right, and then that will be my axis of the curve, because that will divide my curve into two equal half, right? Two equal, I don't know how you can explain it, two equal loops, right? So that is the horizontal line, y equals to 1. So that is c equals to 1. So this here means c is equals to 1. And the amplitude will be between 1 and negative 2. So it's 1 minus minus 2 gives you 3. Amplitude basically is just the height of your curve, okay? From your axis of the curve, from y equals to c. Okay, but because this is an inverted curve, the amplitude is 3. Amplitude is always positive because you're talking about the height of the curve from your axis of the curve. However, because this is an inverted curve, your a must be negative 3. So putting all this into your formula, all right, your curve, the name for this curve will be y equals to negative 3 sine half x plus 1. Right, I'm going to provide you with a summary of how you find the amplitude of a sine functions. There are two ways of finding the amplitude, and depends on the kind of information you're given in the questions. Right, so if you are given the sine function itself, like y equals to 2 sine 3x plus 4, example, or y equals to negative 4 sine 6x plus 7, right, then the amplitude would just be the positive values of a, because amplitude refers to the height of the curve, right? So it has to be always the positive values of a, right? That's one way. A second way is if you're given the maximum minimum values of y. Sometimes in the questions you'll be told that the maximum values of y in this particular sine curve is 6, the minimum value is negative 2. Then how can you use that to find your amplitude? Yes, basically you just take the maximum value of y minus the minimum value of y, divide by 2. That will give you the amplitude, that will give you the height of the curve from the axis of the curve, okay, from your y equals to c. Right, then how do you go about finding the period? So if you're given the trigo functions, the sine functions, then the period is just 360 degrees or 2 pi divided by b. Right, but if you're not given the trigo functions, but you're given a diagram, then how do you go about finding it? Yes, so if you're given the diagram, then first thing first, you have to identify one cycle, because the one cycle will gives you the period. So here the one cycle is the one highlighted in blue for you. You start with you must remember you start with 1 here and you end with 1 here. So that's one cycle. Okay, and so the period will be from the one that highlighted for you in green, that's from 0 to 180. Okay, so this is one way of finding the period if you're given the diagram. How about finding y equals to c? Yes, to find y equals to c, basically you just take your maximum y value plus your minimum y value divided by 2. Right, we're going to look at an O-level exam questions on the sine functions in the next slide. Right, so let's look at this question. So you're given the diagram. In this case, you're given the diagram. You're also given the formula for the trigo function, which is y equals to a sine bx plus c, given here. Okay, and the range given is between 0 to pi over 2 inclusive. Here we're using radians, so you have to take note of that. and the curve has a maximum point at pi over 8, 2, minimum point at 3 pi over 8, negative 8. Right, so for part A, you're asked to explain why c is equal to negative 3. Basically, when you're asked to explain something, you just need to show your working. That means you need to show the steps on how you can actually finally get c equals to negative 3. So if you were to recall to find the values of c, you just take your maximum value of y plus the minimum value of y, then divide by 2. Right, so that's how you get negative 3. So basically, you've explained it. So for part B, we need to explain why b is equals to 4. Right, so if you were to recall to find the periods for this sine curve, you take 360 degrees divide by b, or 2 pi divided by b. In this case here, we're using 2 pi because the unit given it's in radian. Right, so we need to find the period from the diagram given, and you can see that that is 1 cycle. Right, so that's 1 cycle, and then the period will be between, yes, the one highlighted in brown for you. So that will be your period, which is between 0 to pi over 2. So the period is pi over 2. So substituting that into your formula, 360 degrees divide 2 pi over b. Sorry, we don't use 360, we use 2 pi over b equals to pi over 2. We do a cross multiply. You will get b pi equals to 4 pi. So b is 4 pi divided by pi gives you 4. Right, so that's how we find the values of b. Okay, finally, we need to find the equations of the curve. So we still have one more thing to do, and to find the amplitude. So to find the amplitude, do you remember the formula? Yes, to take the maximum y minus the minimum y divided by 2. Right, so a is equals to 5. In this case, we're talking about the upright curve, not the inverted one. So a is equals to 5. So putting all this thing into your formula, y equals to a sine bx plus c. So the equations will be 5 sine y equals to 5 sine 4x minus 3. Okay, so this is one possible O-level questions. Possible exam questions you may see. Right, so congratulations, we have made it to the sine curve. So in the next video, I will show you how we can manage the cosine curve and the tangent curve. So please keep in touch.